Welcome back, guys. As we were discussing about the ls command, ls, which lists all the files that are in the current directory, now comes down to -l option. Okay, so -l, press enter. Okay, so that's quite a big output. I will explain each and everything in a while. Okay, so first of all comes down with total 68. Yeah, this total 68 indicates that the total number of disk blocks that the files in the current directory have occupied. Okay, so all these files have occupied 68 disk blocks. Generally, each block in Unix is of 1024 bytes, but this is something which can be changed to some other multiple of 512. Okay, so Unix treats all entities, files, directories, devices as files only, as we have discussed earlier. Thus, to distinguish between all of them, it uses file types. In fact, in all the lines listed in the output of the command ls-l, as you can see, the leftmost character indicates this type, that is file type. A minus indicates that the file is an ordinary file, this minus, whereas a D indicates that it is a directory. As you can see, D denotes it is a directory, that is this is a directory, and ample is a file, which is denoted by minus sign. Okay, so other possible file types are minus for ordinary files, D for directory file. There is something called C and B. C stands for character special file, B stands for block special file, and there are so many others too, like L, S, P, M, L for symbolic link, S for semaphore, P for named pipe, and M for shared memory file. Okay, so the character special file, which is denoted by C, and the block special file, which is denoted by B, are normally present in the dev directory. These files are used to handle characters-oriented devices like terminals or block-oriented devices like disk. When these files are listed, the file size entry for these files is replaced by major and minor device number. Okay, so usually these files are never found in users directory. These are present in dev directory, and the symbol will be C and B. For C for character special file, B for block special file. Now, most important, the next 9 characters following the file type characters are the file permissions. These 9 characters are the file permissions. Each column in succession gives the number of links. This is the number of links. This is the owner name. This is the group name. This is the size of file in bytes. This is the date and time when the file was last modified, and finally the file name or the directory name. Okay, see, the concept of an owner comes with multi-user operating system. By default, the person who creates the file is the owner of that file. A group may be formed of a given number of users who may be working on similar data. Okay, so how many links the file has essentially determines by how many different names the file is accessible. Suppose this is 4, so this file, or you can say directory, because directory is also treated as file, so I'm gonna say file. This links, what represent this? This is the link is 4, and it represents that this file is accessible by 4 names. This file is accessible by 4 names. When a file has 2 links, it is not physically present at 2 places but can be referred to by either of the names. This is a very useful feature. If you accidentally delete a file with a single link or a single name, there is no bringing it back, as Unix has no file and delete facility. But if a file has 2 links, thereby 2 names, your file is safe. Even if one of the links gets severed or deleted, a link is severed when the file is deleted. Okay, so if a file is very important for you and you want to avoid its accidental deletion, you should establish more than one link for such a file. The command to do so is fairly straightforward, that is ln for link, and then suppose I want to create a link for gain. Okay, one more link for gain, ln gain, and then suppose my gain. Okay, so this is the new name to the given to this file, and it will create two links. Okay, now again ls minus l. Now you can see for, I think, gain. Where is gain? Yeah, as you can see, the gain has got now two links, and my gain also has been listed, which also gets two links. This is not the similar to copy function. They are not copied. They can be referred to. These are just two names referring to gain file only. Okay. This established one more link for the file my gain in the form of the name gain. If you now take a long listing, you would find that both of these files have been listed, as you can see, gain and my gain. The concept of having several links to a file offers another advantage. If one file is to be shared between several users, instead of giving each user a separate copy of the same file, we can create link of this file in each user's directory. This avoids unnecessary duplication of the same file contents in different directories. As you can see, by default, any new file that we create has one link, whereas any new directory we create has two links. Why two links for a directory? Because that directory name appears in two directory files. For example, if we create a directory dir1 in a directory, suppose Gourav, the directory file dir1 or Gourav, sorry, I'm confusing in between the two. Okay, as you can see, directory has okay, I will show you by example. First of all, I will go to desktop only, so that it will be easy for us to implement. cd desktop, change directory to desktop, and then I will create a new folder or directory, suppose Gourav. Right, now I will do ls minus l. What the crap, ls minus l. Now as you can see, the one directory Gourav that I have just created, it has two links. That means it can be referred with two names. This is because the directory file Gourav would have an entry dir1, whereas the directory file dir1 it all itself also. Okay, it may be confusing now. When you open this cd desktop, cd Gourav, right, now put ls. Okay, so ls minus a because of the hidden files, right? As you can see, dot refers to current directory and double dot refers to parent directory. Double dot, single dot refers to Gourav only, and double dot refers to here desktop. As you can see, desktop is the parent of Gourav. So as you can see, we can refer to this Gourav directory by its name and via this single dot. So we can refer to this directory by its name only, by its name as well as this dot. So that's why it has two links. So that's why all directories that we created newly have two links. Okay. Now let us get back to possibly the most important field in the output of ls-l, the permission field. The permission signifies who all can access the file and for what purpose. This is decided by the file permissions. A set of 9 characters denotes these permissions. Let us now take a closer look at these permissions, that are these 9 permissions. There are 3 types of permissions to a file: read, write, and execute. R stands for read, W stands for write, and X stands for execute, as you can see here. Okay, so there are 3 entities to which any combination of these permissions are assigned. These entities are the owner, the group, and the rest, that is the outside of the group. These first three characters belong to owner of the file. These 3 characters belong to group, and the rest 3 characters belongs to the outside of the group. Of the 9 characters, the first 3 characters decide the permission held by the owner of the file. The next set of 3 characters specify the permissions for other users in the group to which the file owner belongs, while the last set decides the permission for the users outside the group. Out of 3 characters belonging to each set, the first character is for indicating the read permission, the second character is for write permission, and the last is for execute permission, and it will follow the same sequence. Okay, so the permission for the file, let's say example 10. Okay, so this was the file that we have created in the previous video. This file has this file will have, for this file the owner will have read permission, write permission, but not execute permission, which is denoted by hyphen here. Okay, and for the group owners to which owner belongs, that group will have only the read permission but not write and execute permission. And the last, the users which are outside of the group or outsiders will only have the read permission and not write permission, neither execute permission, as you can see. Okay, so these permission can be encoded numerically as well. The weights assigned to 3 permissions are as follows, that is read permission, the weight will be 4, write permission, the weight will be 2, I will write it somewhere, read for 4, write for 2, and execute for 1. Okay, these are the weights assigned to these permissions. Thus, when all 3 permissions are available, the total weightage or value will be 7, that is 4 plus 2 plus 1, 7. Okay, the group permission of this file 10, the group permission, okay, I am telling you the group permission here will be only 4, and the outsider permission will also be 4, but the owner permission will be 4 plus 2, that is 6. Okay, get it? In a nutshell, therefore, we can say this permission, this file permission has, this 10 has the permission 6, 4 and 4, 644, that is 644 for 10 file. 644 is the permission that has 10 file. Okay, when everybody has all the permissions, that is when everybody has all the permission, that is RWX, 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 RWX. When you see something like this over here, over these 9 characters, it means that it is 777, and it means that it has all the permissions to all the files, to all the owners, groups and users and outsiders. Okay, so the existing file permission can be changed by the owner of the file or by the super user. The way to change this permission is by using the chmod command. It changes the mode of the file it is executed on. If we want the owner of the 10 to have all permissions and the group and others none, we can simply say that chmod, then the numeric value, or it will be like 710, right? Okay, so first of all I need to go back to this directory, that is home directory, home and Gourav directory, where this file is located, and then I can say this. So do simply like cd ... and then again cd dot dot, and then change mode 700, and then file name 10. And now whenever I list all the files, as you can see, the 10 file that has been modified has been highlighted. Okay, that's cool. And as you can see, it has the owner to have, it allows the owner to have all the permissions, and the group and outsiders have none permission. Okay, so that's how you gonna do this change via change mode command. If you now take a long listing, you can see the result here. This way of changing file permission is referred to as the absolute mode. There is another syntax for change mode, that is chmod, that changes permission, which constitutes the symbolic mode. Its general form is change mode, then comes down to who, then plus or minus or equal, then permission, and then file name. Okay, so the who here refers to whom the permissions are to be assigned. It may be the user or owner, which is denoted by U, user denoted by U, or the group, which is denoted by G, or the others, which is denoted by O, or the outsiders. Okay, so if none is specified, all are assumed. This is the very important point. The plus refers to add permission, minus refers to remove permission, and equal simply instructs chmod to add the specified permission and take away all others if present. The specified permission of course can be RW or X. The command to give write permission to all would be something like this. Okay, I will change it to change mode plus W, and then file name 10. Okay, so this will simply give write permission to all members. ls minus l. As you can see, what the crap. What I have done, change mode plus W and then 10. Seems good. 10. Okay. What's wrong with it? Let me pause the video and search for the solution. Okay, so the statement that I have already told you was wrong, that if none is specified, all are assumed. That is, if I do something like change mode and plus W, if nothing has been specified here before plus, that is neither U or G or others, then it won't be assumed, that it won't assume anything, it won't work. Okay, so you need to specify whether you want to change the permission for, whether you want to give write permission, as in this example, to whom, either user or group or others. Okay, so for the simplicity and for the better understanding, I will create a file here in desktop. As you can see, touch sample, the file has been created, and when I do ls minus l here, you can see sample file and all the permissions here. Okay, so rw minus r minus minus r minus minus. Okay, so now we will do some practices on change mode. or chmod. Now I want to give, in order to take away execute permission from others as well as group, we would say something like this: chmod G for groups, O for others, minus X. As you can see already, this has been already done here. Yeah, as I told you, minus the execute permission, groups and others do not have already execute permission. So instead we need to give execute permission to groups and others. We would say something like this: chmod go plus X and then file name sample. And now when I do the listing, now you can see the group and others have got the execute permission. Now if we are to give a read permission to group and others and take away their write permission for a file, then we would say something like this: chmod go plus R comma go minus W and then file name sample. Now again do the listing, and now as you can see, group and others have got read permission, as you can see here, and group and others don't have now write permission, as you can see here. Okay, now tell me what would happen if I do something like this: go equal R comma u equal rw sample. Now tell me the output. Do it in your mind. Okay, so enough of time, I will explain. This removes all existing permission and replaces them with read permission for group and others, as you can see here, and others, and read and write permission for owner of the file, as you can see here. Okay, it has removed all the permission and assigned these specified permissions to specified person, or you can say person. Okay, now you can say something like, we have done the numbering part. Okay, now tell me the answer of this: chmod 744 sample. What should be the output? What should be the permission given to the each individual? Tell me in your mind only. Calculate that faster. Done? Okay, now I would tell you the answer. This would assign the permission rwx, that is rwx for user or owner, r minus minus for group, and r minus minus for others, as you can see here. 7 is 4 plus 2 plus 1, that is all permissions. 4 means only the read permission, and 4 again means only the read permission, as you can see here. rwx, r minus minus, r minus minus. Very good. Okay, now comes down to masking file permissions. Let us first create an empty file called sample2. Here, touch sample2, and then try to list it ls minus l. How come that the file permission for this file have been set to 644, as you can see here from here. This stands for rw minus stands for 6, r minus minus for 4, and r minus minus again for 4. Ideally speaking, whenever you create a file, Unix should ask you what permission you would like to set for the file, but then Unix never feeds upon you. That is, it assumes that you are an intelligent user who understands the importance of file security and then sets up certain default permission for the files that you create. what Unix does is it uses the value stored in a variable called Umask to decide the default permissions. Umask stands for user file creation mask. The term mask implying which permission to mask or hide. The Umask value tells Unix which of the three permissions are to be denied rather than granted. Got it? The current value of Umask can be easily determined by just typing Umask as I did and just press enter. And as you can see here, the first 0 indicates that what follows is an octal number. Okay, that is 022 will be an octal number. The 3 digit that follows the first 0 refers to the permission to be denied to the owner, group and others. This means that for the owner no permission is denied, as you can see from 0, whereas for both the group and others a write permission, that is 2, is denied. Whenever a file is created, Unix assumes that the permission for this file should be 666. But since our Umask value is 022, Unix subtracts this value from the default system wide permission, that is 666, resulting in a value 644. This value is then used as the permission for the file that you create. That is the reason why the permission turned out to be 644 or rw minus r minus minus r minus minus for the file sample2 that we just created. Got it? Similarly, system wide default permission for a directory are 777. This means that whenever we create a directory, its permission would be 777 minus the value of Umask, that is 022, which gives 755. You must be wondering of what significance would execute permission be for a directory, since we are never going to execute a directory, right? But remember, execute permission for a directory has a special significance. If a directory doesn't have an execute permission, we can never enter into it. Got it? Can we not change the current Umask value? You may be arguing that, yeah, you can very easily. All that we have to say is something like Umask and then 242, whatever will be the value that you want to give, and then press enter. And that's it. This would see to it that here onwards any new file that you create would have the permission 424, that is 666 by default minus 242, which gives 424, right? And any directory that you create would have the permission 777 minus 242, which gives 535. Okay, now we can test it. Something like create another file called touch sample3 and then ls minus l, and as you can see we have got write permission, that is we have got our Umask was 242, that is we should get the permission of 424, right? 4 stands for read, that is we only got the read permission. 2 stands for write, that is we only got the write permission for the groups, and 4 stands for again read, that is we only got the read permission for the outsiders. Got it? Umask got it. Now okay, so this is it for this video. Hope you like this video. Please rate, comment and subscribe, and if you find any difficulty then just comment below. I will answer each and every question. Okay, thanks for watching. Bye bye.